A good day to everyone. You are with Mr. Dambuza here, your friend in mathematics, that is going to help to impact these probability types questions, which are not difficult but challenging, of course, because they invite your maximum analytic skill that is going to help you to unpack and take all this scenario to a mathematical language. So now, otherwise, if you really want to give it a try, you can pause the video, then therefore you come back later for a confirmation of your solutions that you got. So let's go together with this one. The statement reads as follows. 6 different mathematics books and 5 different physical sciences books have to be arranged on a shelf, right? So we are having 1, 2, 3, 4, 5, 6 mathematics books. Then we also have 1, 2, 3, 4, 5 physical sciences books. We are having this physical presentation about the shelf that we are having. Now let's go to the conditions. How many arrangements can be made if all the mathematics books are put together? That means we probably have these books that are going to be put together, not separated. No physical sciences books that will be found between these mathematics books, which means we just treat this one as one unit. And also the physical sciences books are also treated as one unit because they are to be put together as well. So how many different arrangements can be made if we have this kind of situation? All right, so we all know that this is mathematics, 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 this is mathematics. And remember, these mathematics books are different to each other. Of course, we cannot repeat a book when we have put it in this position. We cannot put the same book in this next position. So this is the repetition is automatically not allowed in this kind of questions. So also in this one we have physical science, physical science, physical science, physical science. So which means in this slot we can arrange these mathematics books in how many ways? 1, 2, 3, 4, 5, 6. Since they are 6, they can arrange themselves in 6 factorial. All right, let me just use this color. They can arrange themselves in 6 factorial. Okay, so we just treated them as just one unit. So we also come to physical sciences books. Since they are 5, they can arrange themselves in 5 factorial. Okay, so we have this one, and we know that there is a multiplication in between of these two things. But it is not compulsory, or it's not compulsory that we start with the mathematics. We can start with this physical science, which means this physical science can move to the first 5 slots, then mathematics books can go to the last 6 slots. So the arrangement can be done in 2 ways. That means now we are just gonna be saying times 2 factorial, because these 2 groups, 1, 2, can arrange themselves in 2 factorials, not forgetting that the subgroups can arrange themselves into each number of books or of mathematics and each number of books of physical sciences. So we have 6 factorial for mathematics, we have 5 factorial for physical sciences. Because we have 2 groups, these groups can arrange themselves in 2 factorial. So that is what we have. So we can press our calculator and find out the real answer about that. Otherwise, this is how it's done. See in the next one. All right, let's consider this question. The digits from 0 to 9 are used to form codes. Determine the number of different 6-digit codes that can be formed if repetition of digits is allowed. Now, for the digits to be repeated, we now need to know that because we have 6 different digit codes, which means 1, 2, 3, 4, 5, 6, that can be formed if the repetition of digit is allowed, then therefore how many that can occupy the first position. We have 10 of them that have a chance, 1 out of 10 that have a chance to occupy the first one. Then we also have 1 out of 10 that can occupy the second one, 1 out of 10, 1 out of 10, 1 out of 10, 1 out of 10, because now we can repeat what we have already put in this previous position to the next position. So that is why we are having now, this is 10 to the power of 6. So 10 times 10 times 10 times 10 times 10. So you can see that this is just 1 million. This is just 1 million. So we have 1 million number of different 6-digit codes that can be formed if the repetition is allowed. Moving to the next question. The next question says, determine the number of 6-digit codes that can be formed that starts with a 9 and end with a 2 if the repetition of digits is not allowed. Now we know that since we have 6-digit code, which means in the place of the first slot will be occupied by 9. So how many digit that can occupy the first position? It's only 1 digit, which is this 9 we're talking about. Then therefore and ends with 2, which means how many that can occupy the last one, which is just 1, which is the 2 that we are talking about. So we have that. So now, because the repetition is not allowed, out of 10, that now we have already used 2 of them and we cannot repeat them, which means we are left with what? We are left with 8 numbers that can occupy the remaining slots. So that means on that note, we are having 8 that can occupy the second one. We have 7 that can occupy the third one. Then we have 6. Then we have 5. So we have these ones. If the repetition is not allowed, then therefore it can take us to 1618, right? So this is what we have. Or some, they can just use the permutation button that we have 8 remaining ones, and you just have only 4 slots remaining, right? Which is this one and that one and that one and that one. So if we press that in the calculator, we will definitely get 1680. So the permutation, right? So that means we are having this kind of situation for this problem. Done. See you in the next one. Grade 12s, welcome to the similar question. It reads as follows. The letters in the word curriculum are arranged to form other words. Assume that all words have meaning, right? Now the first question says, how many different letter arrangements are possible? How many different letter arrangements are possible? If you consider this word, you will see that there are letters that are repeated, right? So we need to also deal with them accordingly. So before that, how many letters that are there in this word, regardless of this one is repeated, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 letters. So for 12.2.1, we are having 10 factorial, right? Because we have 10 of them. But out of these 10, we are having 2 R's, then we also have 2 C's. We also have 3 U's, right? And others are just not repeated. So that is why we also need to consider these repetitions now of these alphabets in this word curriculum. So R's is repeated twice, which means we are going to have 2 factorial, then times. Then C is repeated twice, then we'll be having 2 factorial, then times. Then U is repeated 3 times, then we're going to be having 3 factorial. So whatever that you get there is going to be the answer or the total arrangement when we follow this condition. So on that note, the calculator is going to give us, we have 2 times 2 times 3 factorial. Then the answer is going to be 151200. So this is just what we have for number 1. Number 2, it says, what is the probability that the word will start and end with the letter U? 4 marks. So the letter will start and end with the letter U. So if we can open this space for physical look, 1 2 3 4 5 6 7 8 9 10. So you will see that U must start and also end. Because we had 3 U's already in this letter, which means we have only 1 U that is going to be arranged in between of these other slots, right? Which means this U will arrange itself in 1 factorial, and this U will arrange itself with 1 factorial. Né? So these are the ones will arrange themselves in 8 factorial, because we had 10, then 2 are arranged already, so you are left with 8 letters to be arranged. So we have 8 7 6 5 4 3 2 1. But not forgetting that there are some of the letters that are still repeated. Only U that is being taken out, but R, we still have 2 R's. Then we also have 2 C's that we are going to consider by dividing by 2 R's, then times 2 C's. So it's the same way as to say 1 times 8 factorial, then times 1, then divided by 2 factorial times 2 factorial. Then therefore we get the solution on that. We have 8 factorial divided by 2 times 2. Then therefore this is 10080. So this is this is just what we have. This is the number of arrangements that we have if U starts and end, but we are not done because they are looking for the probability. So whenever you are done answering a question, you have to go back and reread the question to check whether you have answered what was required. So here they are looking for the probability. We only have the number of arrangements. So when you calculate the probability, you always divide by the total number of arrangements that are possible, which means now 15, 12, 100. So we have 15, 12, 100. So we have that. So we can now press the calculator to find the probability of this situation. Then 15, 12, 0. So the answer is 1/15. So this is the answer. This is the probability. This is the probability that the word will start and end with the letter U. So this is just what we have, nothing else. See you in the next one. Right, let's consider this question as well, but if you really want to try it, you can pause the video and come back later for the solution. Otherwise, for that being said, let's begin. Consider the letters of the word probability. Now, how many unique word arrangements can be made from this word if the repeated letters are treated as identical? So which means B and B is just the same thing. So we just need to know how do we treat that condition when it comes to answering this question. So 5.2.1, we need to know how many number of letters that creates the word probability. Okay? So 1 2 3 4 5 6 7 8 9 10 11. So we have 11 letters that are used for this word probability. So that means it without any doubt we have 11 factorial. But now because the repeated letters are treated as identical, so we need to avoid to repeat something which is itself. right? So we need now to check which alphabets that are repeated and how many of them. So we have B and B that are repeated twice, so we need to avoid that by dividing by 2 factorial. If we had 3 B's, we would say divided by 3 factorial. If we had just 1 B, there would be any change because we'll just divide by 1 factorial. This is what we are doing for other letters that are not repeated. That is why we don't show that 1 factorial, because it won't make any change, right? So where do we have another letter that is repeating itself? Yes, we have I there. It's repeating it twice. We have I plus I. We have 2 I's. So which means we are going to divide by another 2 factorial because we have I and B's. So we have 2 B's. So that is why we have 2 factorial. Then we also have 2 I's. That is why we have this other 2 factorial. So we always treat that when we have two repeated letters in a word, especially when the letters are treated, especially those letters that are repeated are treated as identical. So we always do this one. Otherwise, if the first B was different from the second B and the first I was different from the second I, there would be any reason for us to divide by how many repetitions the letters are contained, right? So we only do that when the letters are treated as identical, so that we avoid writing B after we have written it already. So this is what we have. So we have 11 factorial, which is the total number of letters that are used to that probability word, then therefore divided by how many letters that are repeating themselves. To avoid them, we need to divide by the factorial of the number of those letters that are repeating themselves. So on that note, we are going to get the number which is 99 then 79200. I think this is 997,000. Oh no, it's gonna be, yeah, it's gonna be 9,979,200, right? So this is just what we have, and this is the number of arrangements that we can have if we treat those repeated letters as identical. So this is how it's done. So thank you for watching. Let's come to the second question. Second question says, how many unique word arrangements can be made if the word ends with the letter R? So we have this condition now that in these 11 slots, 1 2 3 4 5 6 7 8 9 10 11, in these 11 slots we only have one arrangement that has already arranged itself, that we have R in the last position. So there is no need for us to arrange that R, which means we are left with 10 letters to arrange in this word probability. So which means R is now removed, just left with these few other letters that are 10 of them, right? So we have 10 9 8 7 6 5 4 3 2 1, right? So we have that one, and multiplication in between is very important. Yes, of course, also have that one. Then therefore, because we still have these letters that are repeated themselves, so we just need to say divided by, we still have 2 of them, because R was not part of those letters, so which means the denominator is still not affected. So which is simple to say 10 factorial divided by 2 times factorial times 2 factorial, which is gonna be something amazing, which is what you call this is 907200, right? So I think this is 907,200 were letters that can be formed if R is occupying the last position and not moved, right? So this is what we have. So we can always find ways to pull through these kind of questions. And yeah, with me, I think we are going to do more of these kind of questions, because I really like things that are challenging, because I've been challenged too in my days, and it was not easy. It was really not easy. That is why I see a need to actually give out what I can to the people who needs my help. Not necessarily my help, but help in general. So bear with me that I may bother you, give you some more information about what I think you don't know, right? But just bear with me. Maybe you'll get one that you wanted to hear, but it was just a matter of time. So thank you for watching this question. See you in the next one. Let's consider the question. The digits from 0 to 9 are used to form 10-digit codes. Determine the number of 10-digit codes that can be formed if the 2 and the 3 may not appear next to each other, and if the repetition of digits is not allowed. So how do you go about answering this question? Now, we are having 0 to 9 digits, which means we are having 10 in total. So, to find the number of the digits that can be formed, irregardless of these conditions for 2 and 3 not be next to each other, we need to know that how many digit codes can be formed. Now, because we have 10-digit codes and the repetition is not allowed, that means we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So if the repetition is not allowed and we don't consider this condition, this is what we have, which can be given as just 10 factorial. Now, we really don't want 3 and 2 be together. We just want them not to appear next to each other, which means out of this 10 factorial, we need to subtract the condition where 2 and 3 are next to each other. So on that note, let's say we have all these things up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're gonna have 10 then. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because now we want to treat this condition, this one, we want to treat this 2 and 3 as one unit. We want them to treat them to be next to each other, because we don't want them to be next to each other, but let's just pretend as if they are next to each other. So which means we need to subtract the events where the 2 and 3 are next to each other. So when they are next to each other, we know that we are having 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see that 3 and 2, I just counted them as one unit. So we ended up having 9 possible arrangements to be done out using these 9 numbers now, because these 2 and 3 are treated as what? As one unit. So we ended up having 9 units, which means we are having 9 factorial. We're subtracting 9 factorial times this unit on its own that we treated as one group. It can arrange itself by how many times? 2 factorial. Because 3 and 2 or 2 and 3, then they can arrange them that way. So by doing that, we are having the total, which is 10 factorial, which is when we arrange all of them 10 digits with the repetition not being allowed. Then we subtract the condition whereby 2 and 3 are next to each other, because now this is the condition where 2 and 3 are next to each other. Then we are now subtracting from what we got, which is 10 factorial. So subtracting 9 factorial times 2 factorial. So the answer that we will get is going to be 2903040. So this is just what we have. So the idea of approaching this question when there are things that doesn't supposed to appear next to each other, just make them appear next to each other. Then you subtract what you got from the lump sum. So that is why we have subtracted this, having 2 and 3 next to each other, from this one. So whatever that we get here is going to be the events or the number of 10-digit codes that are formed if 2 and 3 are not next to each other, because we did subtract that condition from the total of 10 factorial. So we are done with this one. Thank you for watching. See you in the next question. Here is another question. It reads as follows: 5 Africans, 3 British citizens, 4 Germans, and 2 Americans arrive for a congress. So we are having 1, 2, 3, 4 groups of people. Then we're going to count how many of them in total, but we only have 4 groups of people for now. Then in how many ways can they be arranged if they sit next to each other in a row? So we want now to arrange them in the combination of, regardless of this is the African, this one is the British, or this one is German. We don't care about their race. We just want to arrange themselves if they are to sit in a row. So the arrangement is to just know the total number of them, because there is no condition that is being brought forward. So we just need to know how many of them. We have 5 Africans, then we have 3 British, then we have 4 Germans, then we have 2 Americans. So in total we are having 8, 12, then 14. So we are having 14 of them. All right, so which means 5.1.1 will be 14 factorial. We can arrange the total number of them who are to be seated in a row in 14 factorial. So this is the total number of arrangement that can be done if all of them are to be arranged in a row. So let's come to number 5.1.2. 5.1.2 says, in how many ways can they be arranged so that those of the same nationality sits together in a row? So which means now we consider the rows, the groups that we have, how many of them. So we have 1, 2, 3, we have 4 groups. So which means we're having 1, 2, 3, 4. Let me use this column. We have 1, 2, 3, 4 groups. But South Africans can be arranged in 5 factorial, because there are 5 in total. Then British citizens can be arranged in 3 factorial. Then Germans can be arranged in 4 factorial. Then Americans can be arranged in 2 factorial. So that means we are having this times that. But let's not forget that it is not compulsory that they are put in the positions that they are in. They can also arrange themselves in how many groups that we have is 4. Then they can arrange themselves also in 4 factorials, because now we arrange the subgroups, then therefore we arrange the groups themselves. So since we have 4 groups, then therefore they can arrange themselves in 4 factorial. So we have all this done, which means if you press a calculator, you have 5 factorial times 3 factorial times 4 factorial times 2 factorial times 4 factorial. So we have such number of arrangements that can be formed, which is 829,000 then 440. So this is the total number of arrangements that can be formed if the same nationality is put together without being separated. So we are having this number of arrangements that can be formed. See you in the next one. Thank you for watching. Now let's come to this one. We are having 3 boys and 4 girls that goes to the cinema. They are seated together in a row as a group, right? So we can say this is the row that we have out of we have 1 2 3 4 5 6 7. So we have 7 of them, hence we have 3 boys plus 4 girls that give us 7 in total. Now calculate the total number of possible ways of arranging the whole group. When they speak about the whole group, they speak about the total number of these people who came to the cinema. So how many in total? They are 7. So we are to arrange them to fit this row. Okay, so on that note, we know that in this position anyone can stay. Out of 7, 1 can sit here. Then out of 6, 1 can sit here. Out of 5, 1 can sit here. Out of 4, out of 3, out of 2, out of 1. So we know that this is the multiplication 1. This is the multiplication 1, which means this is just equivalent to 7 factorial. So when we arrange things, we cannot repeat the person. If one person have seated in the first chair, then we are always eliminating 1 for the second one, for the third one, for the fourth one, for the fifth one, up to the last slot. So you can see that now we have 7 times 6 times 5 times 4 times 3 times 2 times 1, which is the same as 7 factorial. So if you want to write 7 factorial in numbers, then it's going to be 5,040. So this is what we have. So we have 5,040 ways of arranging this whole group in 3.1. So which means now we have 5,040. Then moving to the next question. The next question says, determine the total number of ways of arranging the group if the girls wants to be seated together. So now you can see that the girls, they are now discriminating because now they want to be together. They don't want to be separated by the boy. That means there is no boy that is going to be found between the girls. So the girls must be treated as one thing, that no one can separate them. So you can just treat these 4 girls as just one unit. So if we treat them as one unit, we have 3 boys, then this other one unit. So you can see now we have 4 items in total. But you know that if we are having that kind of situation, these 4 items, they can arrange themselves in 4 factorial. So they can arrange themselves in 4 factorial, which means they can be a boy, a boy, a boy, then these 4 girls, or probably these 4 girls, then a boy, a boy, a boy. Can see that? So which means now we are having all of them being arranged in 4 factorial, irregardless of what happens to the girls. But you know that this one item of girls that contains of 4 girls, they can arrange themselves into 4 factorial as well. The girls themselves, they can arrange themselves into 4 factorial. Then therefore the number of items that we have, including the ones of the girls, they can just what? They can arrange themselves into 4 factorial. Then here we also have 4, then 3, then 2, then 1 times 4, right? So that means we are having this 4 factorial for the 4 items. Then for this other 4 factorial is for the arrangement of girls only into that specified space that they are given. Hence the boy cannot separate the other girls. So we have 4 factorial times 4 factorial. So this is what we have. So 4 factorial times another 4 factorial is going to give us what? It's going to give us 576. So in total. So that is what we have. So number 3, it says calculate the probability that the girls are seated together, which means now remember this is this seated together that we have. Then now they want us to calculate the probability of the girls seated together. So that means the probability of girls seated together is going to be equal to the number of girls seated together, which is 576, divided by the total number of arrangements that can be formed, regardless of the gender, but the total number of them is that 7 factorial that we started with. So whatever that we get there, we're going to find the probability of girls seated together. So that is going to be 576 then divided by 7 factorial. Then that's going to be 0.114, right? So we can just put it this way. That is the probability of the girls seated together without being separated by boys. Now let's come to number 3.4. Number 3.4 says determine the probability that they will all be seated girl, boy, girl, boy, girl, boy, girl, boy. See? So if we can open these lots to make things practically clear, 1, 2, 3, 4, 5, 6, 7. So we have that. So since we have 4 girls in total and we have 3 boys in total, so it is clear that the first one is going to be occupied by girl, right? Then the other one is going to be occupied by girl. The other one is occupied by girl. Then the other one is occupied by girl. So here we have boy, we have boy, we have boy. So that we understand this way of arranging these learners, right? So if you go about writing numbers 1, 2, 3, 4, 5, 6, 7, you can see that for girls we are having 4 of them they have a chance to occupy the first slot. Then 3 of them they have a chance to occupy the third slot. Then 2 of them, then the last one. So you can see that the girls can occupy, they can be arranged in this way. Then the boys, since we have 3 boys, there are 3 that have a chance to occupy the second one. There are 2 that have a chance to occupy the fourth one. There's only 1 that have a chance to occupy the last one. So if you can just multiply all these things, and this is going to give you the number of ways you can arrange the girls and boys in this alternate way. So it is the same way as to say just 4 factorial times 3 factorial, because this is going to be 4 factorial, and then this one is also going to be 3 factorial. So just like that. So otherwise I think it's clear this way, but nonetheless this is just the same thing if you want to be short enough. So now 4 factorial times 3 factorial is just gonna be 144. So after that we are looking forward to the probability that they will all be seated in this way until until all the 7 are seated. So now this is the number of them, then divided by the total number of arrangements that were made. So this is 144 divided by 7 factorial. That is going to give us what? 0.029. So you can just write it this one. Otherwise, this is just how it is. So thank you guys for listening. See you in the next question. Let's look at this question together. But if you really want to give it a try, you can pause the video, then come back later for the solution. Otherwise, this is how it goes. Lwazi and Gwenga are the head boy and the head girl of their school respectively. In addition, there are 3 boys and 2 girls who are prefects. Okay? They are all supposed to sit for 2 photos in a row. So that is the scenario that we have, that we ended up having 2, which is Lwazi and Gwenga, plus 3, which is 5, plus 2, which is 7, which means we have 7 people that we are dealing with. Right. Now, question 1.6.1 says, in their photos, which is order is not important, in how many ways can they sit? Right? So they can sit in 7 factorial because we have 7 of them. So we can arrange them in 7 factorial. How does this 7 factorial goes? It's because before anything else, in the first position, we have 7 people that have equal chances to occupy the first one. Then once that person is seated, then we are left with only 6 that have equal chances to occupy the second one. Then once that one is seated, because we cannot repeat the person, we have 5 chances, we have 4, we have 3, we have 2, we have 1. So this whole thing is just regarded as 7 factorial. So this is why we just write 7 factorial in short. Then therefore, if you press your calculator for 7 factorial, you'll get 5,040 ways that you can have a first photo that is different from others. So we have that kind of a response for number 1. Let's come to number 2. In the second photo, Lwazi and Gwenga, which are these head boy and head girl respectively, can only sit on the 3rd and the 5th seat. Right? Either ways, which means it is not compulsory that this person must sit on this third one, but 2 of them, they have equal chances to occupy these 2 special positions. Now, if we can open these positions for you for practical view, we have 1, 2, 3, 4, 5, 6, 7, which means we don't need this last one. We can see that this condition says Lwazi and Gwenga can only sit on the 3rd and the 5th seat, either way. So that means for Lwazi and Gwenga, 2 of them, they have equal chances to occupy this seat, which is the 3rd seat, of course. Then if one is seated out of these 2 people that are being treated special, then in the 5th seat, which is this one can sit there, right? Because when we have 2 there, we don't say 2 people are going to sit here. We're saying 1 out of 2 can occupy the 3rd one. Then when this one now we have, because this one have seated on the 3rd one, then there's only 1 who can sit on the 5th one, which means we are done with this condition that is in this statement. Okay, let's come to this real question now. What is the probability that the last seat is occupied by a boy and only a girl that can sit on the 4th seat? Okay. Now, they are saying the probability that the last seat is occupied by a boy. You must know how many boys do you have? 3 of them. which means we have 3 boys that have equal chances to occupy the last one, which means 1 out of 3 is going to be there. Then now we are left with how many boys? 2 boys to sit in the empty spaces. Then we also continue with the condition that says, and only a girl that can sit on the 4th seat. And this is the 4th seat. Okay? Only a girl. But how many girls? We have 2 girls. Okay? So now, since we have 2 girls, we have 2 out of them have equal chances to occupy that 4th seat. But not 2 of them can sit there, 1 out of 2, which means we are left with 1 that doesn't have a place to sit. That gives us equal of 3 people who are to be arranged to these remaining seats. That you can say now, out of these 3 peoples, 1 can sit there. Out of 2 the remaining ones, 1 can sit here. Then out of that 1, it's compulsory to go to this 5th, 6th position, just over there. So because now we're dealing with permutation, we can just multiply all these things, then get the answer, which is going to be 72. So this 72 is the total number of photos that can be taken that are different from each other when these conditions are being followed. So we have 72 different photo arrangements for the second photo that can be taken. But now, because they are looking for the probability, this 72 will be divided by the total number of arrangements when there is no condition being followed. Right? So now we can see the answer for this one is going to be 0,0142. Yeah, we can have that one. That is going to be, when we multiply by 100, you will then get 1, which is 1,4, or we can say 1,43%. So we have that kind of situation now, which is the probability that the last seat can be occupied by a boy and only a girl that can occupy the 4th seat. And also we know that Twenga and Lwazi must sit on the 3rd and the 5th seat. So this is what we have. If you enjoyed, please subscribe, and you can post a comment and anything to support the channel. Otherwise, see you in the next one. Bye.